Thank you for joining me for another video from the Math Doc. We're continuing with videos related to linear equations, and specifically we're now going to look at different formulas which are all connected to the idea of literal equations. We discussed literal equations in a previous video where we explained that a literal equation is an equation that has more than one variable in it. And in this case, this video is focusing on the temperature formula, which shows us how to go between measurements in Fahrenheit, which is shown here in F, and measurement in Celsius, which is shown here by C. So we may take our temperature measurement in a thermometer that shows us the result in degrees Celsius, and then we can translate that into a result in Fahrenheit and vice versa. Now, one of the things we learned in the video about literal equations, and if you're new to this channel, I am linking the video to this video, but if you haven't seen it, please take a look at that video first. But one of the things we learned there was how to solve for one of the variables. So in this case here, the equation shows us that C, right, Celsius, equals 5/9 of, in parentheses, F, the measurement in Fahrenheit, minus 32. Now, what this means is that if we get a measurement of the temperature in Fahrenheit, say we say F equals 42, we can use this formula to find what the temperature is in Celsius, right? What we do is we insert 42 within this equation for F, right? And we get the value for C. But what happens if we actually measure in C? In that case, we have to solve for F, right? If our measurement is given in centigrades and we want the measurement in Fahrenheit, we can't go directly this way. We have to solve for the measurement in Fahrenheit. How do we do that? We use our usual linear equation tools. So let's write that out. C equals 5/9 times F minus 32 in parentheses. So we can use the multiplication property to get rid of the of this coefficient here in front of the parentheses. What do? Let's multiply both sides by 9/5. So we have 5/9 here, but in order to neutralize that, what we do is we multiply by the inverse, which is 9/5. So let's do that. We'll do times 9/5 on both sides, and we get 9/5 times C equals 9/5 times 5/9 times F minus 32. But of course, the 9/5 and the 5/9 are reduced, right, to 1. They each cancel the other, and so we're left with just F minus 32. We can get rid of those parentheses because there's nothing multiplying it anymore besides 1. Now we can use the addition property, so we can add 32 to both sides of this equation, and we are left with 9/5 C plus 32 equals minus 32 plus 32 cancel equals F. Okay, so we've basically done what we wanted to do. We've solved for F. So now we have a formula that shows us how to go from centigrade here to Fahrenheit. Okay, and that is what it means to when we say solve for F. If we got this equation, we could say, if we had this equation originally, we could say, well, solve for C. And in that case, we would have to move the 32 over and then multiply by 5/9. Okay, but since we started with this equation here, we only had to solve in one direction. Sometimes our equations are show neither one directly, so we could have had this as 9/5 C equals minus F plus 32 equals 0, in which case we would have to solve for C and solve for F to get the two different formulas, okay? So it depends really on the format that we get for the formula. Okay, and here below is an example of a problem that will use this formula for its solution. So the question is, Beth's school does not allow kids with a temperature above 99 degrees Fahrenheit to come to school. Beth's temperature this morning is 38 degrees Celsius. Can she go to school? Okay, so obviously we have a problem here because we have our requirement, right, is 99 degrees Fahrenheit. That's in Fahrenheit. But our actual measurement of Beth's temperature is in Celsius. So we have to convert one of these numbers, right, to the other unit. So let's convert Beth's temperature. If her temperature is 38 degrees Celsius, we can use the formula we got for when we solved for F, right? We know that 9/5 of the measurements in Celsius plus 32 equals the measurement in Fahrenheit. So let's now substitute 38 degrees for our symbol C here. So we have 9/5 times 38 plus 32 equals F. And we can solve this directly. What is 9/5 of 38? Let's do that here on the side. So let's do 9 times 38. 9 times 8 is 72. Carry over the 7. 9 times 3 is 27. 27 plus 7 is 34. So this is 342. Now we have to divide by 5, right? So we do 342 divide by 5. We're dividing because we multiplied by 9/5. So 5 goes into 3 0 times, but it goes into 34 6 times. So we have 6 times 5, that's 30. Let's bring down our 4 here and our 2, so 42. 42 divided by 5 is 8, so that's 68. 8 times 5 is 40. We have a 2 here. 5 goes into 2 0 times, but we can go over one decimal spot by adding a 0, so we have 20, and 20 divided by 5 is just 4, right? So we put in our decimal point here, and we find that 9/5 of 38 is 68.4. So this equals 68.4 plus 32 equals F. Now let's add these two numbers together. 68.4 plus 32. 4. 8 plus 2 is 10. So we carry over the 1, and we have 100.4. So Beth's temperature is 104 degrees when measured in Fahrenheit, and that is more than 99 degrees, right? So Beth cannot go to school. So the answer is nope. Beth cannot go to school. And all we did here was we first solved for the F in this literal equation, right? We had the literal equation for the measurement in Celsius and Fahrenheit. We solved for F, and then we used the solution to compare the two temperatures. So that was work with our first formula, which is the temperature formula, an example for a literal equation. Thanks for joining me. If this video was helpful, please like. If you have questions or feedback, please comment, and we'll be glad to see you in our next video that will be dealing with a different formula. Thanks.